Okay, so today we're going over the indefinite integral. Okay, we saw a definite integral, and it's the integral of f of t dt from a to b, this meaning that it's a definite integral. So an indefinite integral does not have the upper and lower limits of integration. Okay, as you can see, there's none there. So this is where we just write the, and that's why you need to know the antiderivative for it. And this is an overemphasis, okay, from what I had done before. It's making you write the plus c. It's that constant of integration. It's an arbitrary constant, okay? It's any constant. At this point, since we're familiar with integrals, okay, and now we have to do indefinite integrals, there's no plugging into anymore. We're just going to go over something else, and that is our formulas, okay? So we're going to go over the first one. It's a main one. Okay, please make sure you copy it down. And it is the integral of x to some power of n with respect to x. Okay, and if it's not x and it's like beta or something, that would be d theta. In any case, let's go back to the general x to the nth power that we see as our integrands. What we're going to do is add 1 to our exponent and divide by that new exponent. Don't forget to write plus c. And the only thing here is that when we do have this expression, n cannot be -1 because therefore it would not exist. It would be not defined or undefined. Okay, so if you're doing something and that's going to be the case, you're going to have to do like -1 in there. It's not going to work. So it's going to come down the road. That's number 1. Again, make sure that you copy it down. So number 2 and number 3, I kept one there just in case. So number 2, if you have the integral of 1 over x dx, or if it's multiplied, like compacted, you have the integral of dx over x. This is important. This is memorized as the ln of the absolute value of x plus c. Okay, don't forget that absolute value part. As you can tell, I kind of like made my voice go slower so that you can understand that that needs to be there. Okay, so enough with the jokes. Let's move on to number 3. So this is the integral of e to the kx with respect to x. So this is e to the kx divided by k. Before you have to write the plus c, please remember to write the plus c. Okay, and that's why when I taught you the definite integrals, that you had that understanding of what an antiderivative was and what the antiderivative is, so that you can get used to having that plus c. In any case, these are 3 formulas, okay? These are the main ones that you need to know. Of course, there's one for trig, but we'll get to them at a later date and time. Since these are the main ones, we're going to work with these first in cooperation with some of the properties that we went over, okay? These are the same properties that I went over with the definite integral. Okay, so if you have a constant multiplied by your function of x, you can take that constant out. We're calling that k. So that way it's a little bit different than the c that we have to write when we have to write plus c. And if there's more than one expression, you can take the integral of each expression, especially if there's like a combination of different things some way, somehow. Just remember you can do that. All right. So let's get to some examples. If you didn't copy it down, make sure that you do. I'm going to erase this and leave the bottom slide on. Okay. So again, I just want to leave the bottom slide on so you have that reference, or if you didn't copy it, you still have the time to do that as I start to go through the examples. So number 1. So we're going to integrate actually each term in our integrands with respect to x, because that's what we can do each term individually. You don't have to show this part, but you can actually just do it. So since we have x to some power, either 5/2 or 1, then we're going to use our first rule. Okay, I know I took it away, but hopefully you copy it, look in your notes. We're going to add 1 to our exponent and divide by that new exponent. So since you already show that addition of 1, so 5/2 plus, let's say 2/2 is 7/2. We'll simplify in a little bit. Now we're going to do it for the second term. Grab another color here. So for the second term, we're adding 1 to 1, and we're dividing by that new exponent. Okay? And last but not least, the most important part, or it's most important because kids forget this when they write their indefinite integral answers, the plus c. Okay, now to simplify it, we're dividing by these fractions, so be careful. Remember, keep, change, flip. It's going to be 2/7 x to 7/2 power plus 1/2, or you can keep it as x squared over 2 plus c. So this is the answer for number 1. Okay, make sure that you have it down. I'm going to go to number 2. Okay, so for number 2, okay, we have 2,000 in our numerator, we have x in our denominator. So just to kind of point out to you, I can take the 2,000 out in front of the integral. That way, everyone can see that this is the second rule that I was showing you before, because this is the same as dx over x. So you don't have to write this part, but I just want to show some students it is that formula there. So that means I'm going to have 2,000 times the ln of the absolute value of x plus c, okay? And that actually is running out of room, so I'm going to erase some of this up here. You know what, I'm just going to take off the last slide. Okay, so that way we have plenty of room. So 2,000 would be distributed to the ln absolute value of x, and if 2,000 is distributed to our constant, it's still a constant. Okay, so don't worry. I didn't just throw it out the window. It's there. But if it's 2,000 times 1, it's 2,000. It's a constant. It's c. If it's 2,000 times 5, okay, then it's 10,000, and it's still a constant c. So that's our answer for number 2. And let's do number 3. Okay, so now we have plenty of space. We can do number 3. So in number 3, we see the integral of e to negative 3x with respect to x. We're going to write it using our formulas. And you can actually keep it like this, or you can pull out the negative 1/3, and you're good to go. Good luck!